Bismillahirrahmanirrahim. Assalamu alaikum students. Today we are going to start Mathematics book 7, chapter number 5. And the name of chapter is Square Roots of Positive Numbers. The topics of this chapter we will cover in two parts. In the first part we will cover square, perfect square and properties of perfect square. Now what is a square? You are all familiar with this word as a shape. Whereas in mathematics, the square of a number can be defined as the product of a number with itself. How to find the square? A square is the result of multiplying a number by itself. So if we have to find the square of 1, we will multiply it with itself, that is 1 multiplied by 1, and we will get its square, that is again equal to 1. If we need to find the square of 2, then we will multiply 2 with itself and we will get 4, which is the square of 2. Similarly, for 3 and 4, we will get the squares 9 and 16 respectively. Perfect squares. A natural number is called a perfect square if it is a square of any natural number. For example, 1, 4, 9, 16, 25. These are all perfect squares. How? Because these are all squares of natural numbers. Look at the natural numbers from 1 to 10, and for each number when we are finding the square, that is 1, 4, 9, 16, 25, these are all perfect squares because these are the squares of natural numbers. To test whether a number is a perfect square or not, what we will do, we will find out the prime factors of that given number. And if the prime factors of the given number are grouped in pairs of equal factors, then the given number is a perfect square. Look at the illustration in the colored. If you see here, if 2 is multiplied by 2, we get 4, which is a perfect square because the prime factors are in a pair. 2 multiplied by 2 is a pair of 2. Whereas for the factors of 25, we get 5 multiplied by 5. Again, the factors are in a pair. So number 25 is a perfect square. Whereas number 8 is not a perfect square. Why? Because look at the prime factors of number 8. 2 multiplied by 2 multiplied by 2. So we have 2 here 3 times, which is not making a pair. One pair will be made 2 into 2, but one 2 factor will be left alone. So this is not a perfect square. Similarly, for number 125, when you convert it into prime factors, you will get 5 multiplied by 5 multiplied by 5. First two digits, first two factors will make a pair, but the third 5 will remain alone. Again, this is not a perfect square. So this can be easily identified in simple numbers. Now that we have learned a perfect square number is the product of two equal integers, let's apply this on more complex and bigger numbers. For example, we take 3969 and we do the prime factorization of this number. We end up with the prime factors of 3969, which are 6 digits, making 3 pairs. 3 multiplied by 3, 1 pair. Then again 3 multiplied by 3, another pair. And last is 7 multiplied by 7, the third pair. Since all the prime factors of this number are making pairs of the same numbers, then this number is a perfect square. Whereas we take another number 2352 and do the prime factorization of this number. Here when we do the prime factors and we get 7 factors. First 2 multiplied by 2 making a pair, again another pair of 2 multiplied by 2, whereas number 3 does not make any pair with any factor, and last is 7 multiplied by 7, again making a pair. So if we look at the prime factors of 2352, we see that 3 pairs are made but one factor is left alone, which is not making a pair with any factor. So in such cases, the given number is not a perfect square. We will study the properties of perfect squares of numbers now. The first property states the square of an even number is even. Now look at the squares of even numbers given below. Square of 6 is 6 multiplied by 6 gives 36, which is an even number. Again we take another even number, that is 8. 8 multiplied by 8 gives 64, which is again an even number and square of an even number 8. Property number 2. It states the square of an odd number is odd. Let's find out the squares of some odd numbers. Look at the examples below. Square of 9 is 9 multiplied by 9 gives 81. Now 81 is an odd number and it is the square of number 9, which is also odd number. Similarly, square of 7 multiplied by 7 gives 49. Now 7 and 49 both are odd numbers. The square of a proper fraction is less than itself. So let's take a fraction. Let's say we are taking 3 by 4. When we take its square, the square of 3 by 4 is equal to 3 by 4 multiplied by 3 by 4, which is equal to 9 by 16. Now we have to compare the given fraction with its square. The given fraction is 3 by 4, whereas its square is 9 by 16. How we are going to compare these two fractions? We are going to use the method of cross multiplication, where we will multiply numerator of the first fraction with denominator of the second fraction and multiply the numerator of the second fraction with the denominator of first fraction. So 16 times 3 is 48. This is the result of first fraction, and 9 times 4 is 36, which is the result of second fraction. Now we can compare the two. The first fraction comes out as 48, which is greater than the second fraction 36. Last property, that is fourth property, states the square of a decimal less than 1 is less than the decimal. Let's see. If we take a number that is less than 1, let's say we take 0.05, which is less than 1. Now we take its square. 0.05 square is equal to 0.05 multiplied by 0.05. We can directly multiply it or we can convert it into fractions. Both ways it is going to be correct. We get the answer 0.0025, and we can clearly see that 0.0025 is less than 0.05, that is the original decimal given. Dear students, before we proceed to the second part of the chapter, I would like to remind you that you must practice the related questions of the topics that we have already covered. For your convenience, I have already mentioned the relevant exercises on the slides. Now let's come to the second part of the chapter. In this part, we are going to learn what are square roots and which two methods we are going to use to find the square roots. That is by prime factorization method and by division method. We can find the square root of any square number, and the process of finding the square root is an opposite operation of finding a square. Let's understand this through an example. We take number 3 and find its square. We see that 3 multiplied by 3 gives us 9. Now we take this 9, which is the square of 3, and take the square root of this number 9, which gives us 3. So we end up with the original number by taking the square root of its square. To represent square root, we use a symbol, and this symbol is called radical. Whereas the number under this symbol will be called ready canned. In prime factorization method, we can find the square root in 4 steps. Step 1. Find the prime factors of the given number. Step 2. Take the square root on both sides. Step 3. Write them as pairs of prime factors. Step 4. Write the square root of each perfect square and find their product. Let's apply these steps to a number. We have 1764 here. First of all, we are finding the prime factors of this number and we end up with 6 factors making 3 pairs. First pair 2 multiplied by 2, second pair 3 multiplied by 3 and third pair 7 multiplied by 7. Now you look in the next step, we have taken square root on both sides. By taking square root on both sides, we write the radical sign right above 1764 and on the other hand we write the same radical sign on the factors of this number. In the next step, we have done pairing and written the pair as squares. That is 2 square multiplied by 3 square and multiplied by 7 square. In the next step, we have written these pairs separately with 3 separate radical signs. Next, we take out these pairs and only write the factor once. That is 2 square under root will be written as 2. 3 square under root will be written as 3 and 7 square under root will be written as 7. In the last step, we are going to find the product of these 3 numbers, that is 2 multiplied by 3 multiplied by 7 and we get 42, which is the square root of given number. You must notice that the prime factors of a perfect square are always in the pairs, and if you are not getting the prime factors in pairs, then you will not be able to find out the square root of given number. What if the given number is a fraction or decimal? How we will find the square root of such numbers? Let's look at the first example, which is a fraction, 49 over 81. In such cases, we will do prime factorization of both numbers separately. After finding the prime factors of both numbers, the remaining steps will be the same. That is, we will take the square root on both sides, write them as pairs of prime factors. Once pairs are made, we will write them as squares. In the next step, we will remove squares and square roots simultaneously in the same step because these two cancel each other and we are left with the factor only once, that was previously as square. So here you can see in the second last step that 7 square under root will be written as 7. So you can see that square and the square root sign, they both cancel each other. Similarly, in the denominator, we have 3 square under root multiplied by 3 square under root twice. Again, the squares will cancel the square root signs and we will be left with 3 multiplied by 3. Last step, we will find the product and we will end up with 7 by 9. Now this fraction 7 by 9 is the square root of 49 by 81. Similarly, if we are given with a decimal number, look at the second example. Number is 3.24. The only difference in finding the square root would be the first step. In the first step, we will change this decimal into a fraction and the remaining steps will be the same as we have done in the previous example where we had a fraction. So you see, when we remove the decimal, 3.24 becomes 324 over 100. Now this is a fraction and we will follow the same steps that we have done already with the fraction and we will end up with 18 by 10, that is again a fraction, and we will convert it into decimal. So remember students, when the given number is in decimal, we will change the answer into decimal. with the last step. The other method of finding square root is division method. But students, this is not the regular division method that you have already done in the previous classes. In this division method, you are only given with one number, that is dividend, and divisor is not given. So how we will proceed with the division? Let's see. Step 1. From right to left, make pairs of the digits and show them by putting a bar over each of them. Look at the example. We have made pairs. The first pair is 25 and we have put a bar on top of it. Then second pair is 52 and next pair is 58. So there are three pairs now. Now start the division. First of all, we have to guess the greatest number whose square must be equal to or less than the first pair, which in this case is number 58. So we will, through trial and error, guess that number that is close to 58 or equal to 58. So look in the rough work. First we check 6 square is 36, which is not really very close to number 58. Let's try the next number. 7 square is 49. Well, quite close. Let's check the next number. 8 square is 64, which is greater than 58. So we will not use 8 square. Instead, we will use 7 square because it is the closest to number 58. So the first divisor that we have selected is 7 square. How we write this? 7 we write as divisor, and the next factor, that is 7 square, we write as the first number in quotient place. So 7 sevens are 49. Now we will subtract the square of the number from the pair of the digit. 58 minus 49, and we are left with 9 remainder. Now we will bring down the next pair, that is 52, and the number that we have to divide is 952 now. Now look at the divisor. In this step we will double the quotient and use it as second divisor. So previously we had 7, we will make it double, which will be 14. Now we have to decide the next number with 14 that should be the same in this step and in the quotient. So through trial and error we will try a number that is going to be close or equal to 952. In this case we have 14 already, and we will try from 5. 145 multiplied by 5 gives us 752, which is not quite close to 952. Similarly, through trial we learned that 146 multiplied by 6 is the closest number, 876. So we will use this number, and you can notice that the last number of this divisor, that is 6, is also the same number that we are writing in the quotient place. Next step, we will do subtraction that we regularly do in the regular division also. So 952 minus 876, we will subtract from it, and we are left with 76. In the next step, we bring down the next pair, that is 25. Now the number that we are going to divide is 7625, and again, just like the previous step, we are going to double the quotient and use it as next divisor. So you see here 146 plus 6 gives us 152. So carefully watch that we are going to use the last digit that we add in it. Like previously 146 we are going to add 6 only. We are not making the whole number double, only the last digit will be made double. So now we have 152, and we have to decide a number next to 152 which should be the part of quotient also and give us the number equal or close to 7625. So different trials we will make and learn that number 5 will be the next number in quotient. So we will multiply 1525 with 5 and it gives us exactly the same number that we require, that is 7625. Now the remainder becomes 0. So once the remainder becomes 0, the division process ends. Now the question is, what is the square root? Students, the quotient that we get here, that is 765, is the square root of this given number. If you want to check whether your answer is correct or not, you can take square of 765. That is, you multiply 765 with 765 and check your answer. That will be the given number whose square root we have just found. Let's learn the process of finding the square root of decimals now. The given number here is a 7-digit number. Let's make pairs first. For a decimal, a pairing is a bit different. For the whole number part, that is before the decimal, you start the pairing from right to left. But for the decimal part, you have to pair the number from left to right. Now look at this number. The decimal part, first pair is 96, the second pair is 93. Whereas the whole number part, one pair is 99 and the last digit is left alone. It is not making a pair. We will start the division process now. Look at the first digit that we have to divide, that is 1. So obviously the only square that we can use here is 1. So our first divisor is 1. 1 into 1 gives us 1. We are going to subtract it. 1 minus 1 gives us nothing. We will move the next pair, bring it down, that is 99, and we will choose the second divisor now. As I have already told you that we have to double the divisor. 1 plus 1 gives us 2, and the next number that is going to be decided by trial and error. So the dividend here is 99. So we have to choose a number that comes here after 2, that is giving us a number close or exactly equal to 99. Through trial, we learn that 24 times 4 will give us 96. That is the closest number to our dividend, which is 99 in this step. So we choose that number. 24 times 4 gives 96. We will subtract it from 99. Now this step is important as we are dealing with decimal. After subtracting 96 from 99, we get 3. Before we bring down the next pair, we will move the decimal up in the quotient place, because without moving the decimal point, we cannot bring the next pair down. This step is the only difference between a decimal and a whole number without decimal. Okay, let's proceed with the next step. Now, next pair that we have moved down is 93 and the dividend becomes 393. On the divisor hand, see, we have added the last digit, that is 4, and now we have 28. The next number we have to decide such that it gives us a number close to 393. Again, through trial, we learn that 281 times 1 will give us 281, which is the closest to 393. Again, we subtract 281 from 393 and end up with 112. The last pair, we bring it down and the last divisor will again be judged. After adding 281 plus 1, we get 282. Next number we decide is 4, because 2824 multiplied by 4 gives us the exact required number. In this step, the remainder is 0. So the division process ends here and we have our square root, that is 14.14. Students, take notice that for decimal we don't need to change it into a fraction in division method. Whereas if you are given with a fraction and you need to find the square root by division method, you will separately find out the square roots of numerator and denominator, and you will end up with an answer that is a fraction. I hope this explanation helps you in understanding this chapter. Keep practicing, keep learning.